All right, everybody, welcome to the Daily Space Weather. Thanks for tuning in. Exciting stuff going on. Plenty to cover here at the SMASH News Network, least busted name in news. Starting out with some zoomed-in views here of the closest star, which includes an M-class flare you can see coming out of sunspot 2911. AR 2911 has produced an M-class flare. We didn't even see a coronal mass ejection associated with that. We do have a little bit of lack of coronagraph imagery. We'll get to it. The Solar Dynamics Observatory once again returning some fantastic data in both 304 and 171 angstroms. Sunspot number is at like 128 at the moment. It went from 0 to 128 in 3 days. So here's the colorized magnetogram, and you can see some of the evolution of those sunspots. Likelihood of additional solar flares is certainly there. These sunspots have all been underachievers in terms of producing solar flares. Nearly every one of them is capable of producing significant X-ray increases. Here's a close-up of the southern hemisphere. This is a composite with 131 and 94 angstroms. These wavelengths are specifically for studying solar flare activity. And here's the biggest achiever in terms of X-ray output. Again, sunspot 2911. We thought it would be called 2910 yesterday, but another one formed. So over 100 sunspots, about 130 sunspots at the moment. The radio flux up to 118. So you can see it went from 78 to 118 in about 2 days there. 2 or 3 days, I'll say. That's the 1-year chart. The black line there is the 10.7 centimeter radio flux. The red line is the sunspot number. Again, it looks like it's at 128 at the moment. So we put out a video this morning. You may not have seen this one. It's entitled Solar Dynamics Observatory Catches M-Class Solar Flare. Captures M-Class Solar Flare. Here's a teaser. So check that one out if you haven't. It includes 48-hour videos from the SDO. No space weather storms forecasted at the moment. Don't be surprised to see this suddenly change. There is a coronal mass ejection warning as well as a solar flare warning in effect as a coronal hole wind stream subsides. So we've seen the solar wind speed dip here in the past couple of days. If you look at the Enlil spiral, you can see there is a heap and help and a nothing in the forecast at the moment. So we'll keep you posted on this. If this suddenly changes, we'll probably make another video promptly. Take a look at global seismicity briefly. The largest quake of the past 24 was a 6.0 magnitude near the South Sandwich Islands area. We also saw some deep quakes north of Fiji, north of New Zealand, around Fiji. Two 4.4s, over 500 kilometers estimated depth for those, as well as some quakes at Hawaii, most likely associated with Kilauea and seismic activity. Let's just take a brief look here at Hawaii to see where these quakes are located. You can see that one certainly under Kilauea. And let's just continue up the list here. No major quakes again besides that 6.0 that came in at 2114 Universal Time. A 6.0 in the most seismically active region on the planet at the moment, that South Sandwich Islands tri-plate boundary there, near the South Pacific, South Atlantic, and Antarctican tri-plate boundary. Perhaps an indication of foreshocks. So that is certainly an interesting spot for the past couple of months. That is the most seismically active region on the planet, that area by the South Sandwich Islands. There was a 3.1 near Forks, Montana, also. And leave us a comment if you felt that quake. Let's take a look at volcanoes here briefly. Pyroclastic flow at Semeru. Let's hope nobody was in the way of that. That's not the optimal way to go in a pyroclastic flow. Suwanosejima. Continued activity and a volcanic ash cloud. No indication of the size of it. Don't fly your ultralight aircraft or even your drone over it unless you're willing to lose your drone. Mount Manam on Papua New Guinea. Possible volcanic ash cloud from that. No indication the size. Semeru. Again, pyroclastic flow. About a 14,000-foot ash plume there. No listing on the flight level. Santiaguito now exploding, producing a flight level 150 or a 15,000-foot ash plume over Guatemala. Fuego in that same country, exploding as well. Similarly sized ash plume there, flight level 150. Nevado del Ruiz, no volcanic ash observed in webcam or satellite. Don't assume it's not erupting. Revenador, exploding. That's in Ecuador, and it's producing a 15,000-foot ash plume. Sabancaya in Peru exploding, 25,000-foot ash plume in a continuous ash emission. Fertilizing South America is Sabancaya. Please don't pole vault the caldera. Today's featured product is HIPAA. My vaccination status is none of your business. Now, HIPAA, the Health Insurance Portability and Accountability Act of 1996, did not evaporate last year, although you may have thought it did. We create laws because of crises. We don't evaporate the laws because of the crises. The laws are there to protect us during crises. I don't talk to most doctors about my health. I divulge nothing. I've been an athlete since 1999 on a serious scale. My vaccination status is none of your business. I don't take advice from most doctors, and most of you shouldn't either, because epidemiological data has nothing to do with you as a specific case. Let's continue on. To promote the SMASH team, smashamash.com/SMASH team is where we've replaced Patreon with something vastly superior. Check it out. We're putting up free publicly visible posts through the year 2021. And welcome to the Neo Renaissance. You can find links at the homepage to the SMASho merch as well as the SMASH team. Let's get into magnetic data. Our regular viewers are aware that stellar activity is largely governed or at least associated with the magnetic fields. Here's the GOES magnetometers over the past 3 days. Getting a little higher readings here, little higher highs and higher lows over the past about 12 hours there on the GOES magnetometers. And we're getting some wild swings here in the National Sunspot Observatory data. This is the Gong 2 data, we call it. The PFSS, that stands for Potential Field Surface Source. And there is a North Pole current sheet rushing this way at approximately the speed at which the sun is rotating, which is quite fast, faster than Mercury's orbit. Here's a line of sight view, and you can see the wild swing here in the B field, accompanied by that blue line swinging down there to the south, as there is a massive series of sunspots down there. Here's a coronal hole line of sight plot, and you can see the sun's B field being wildly pulled down there as cycle 25 suddenly takes a huge step in progression forward. So there's what's going on. The line of sight coronal hole plot is probably the best product that you could view in order to view the solar polar field reversal process, which is half of a solar cycle. I should say the solar cycle is half of the solar polar field reversal process, as the North Pole is making its way to the south, believe it or not. That's the way solar cycles operate, folks. Next, a visual here, and you can see this large coronal hole. It is South Pole oriented, as you can see here in the Gong 2 data imagery. I think it's South Pole oriented. If I had to guess, I would say that is a South Pole oriented coronal hole. So that's going to add some additional stuff to the solar system, as there are high speed solar protons, hydrogen nuclei, blasting out of this thing. And let's continue on. The likelihood of major flares remains there. These sunspots have been underperforming. Don't be surprised to see additional radio blackouts. We put it on yesterday's thumbnail. Expect radio blackouts. These sunspots have been underperforming. Don't be surprised to see M or even X-class flares from these groups of sunspots. They're all significant. There's only one here showing up as an alpha class. All of those beta class sunspots are indeed likely to produce major flares. There was only one major flare in the past 3 days. You can see this M-class flare that we showed you earlier, we'll show you at the end also, occurred just after midnight at 0:50 universal time. It did not send any relativistic particles, at least none that have showed up yet. The likelihood of that is getting lower and lower. And let's take a look at the real-time solar wind, which again has subsided. So now we're down to more like 400 kilometers per second. And the solar wind density only at 7.16. Pretty much unremarkable solar wind data there at the moment. The KP index is at 1. And for you new viewers, that's a measurement of global geomagnetism. It's a geomagnetic calm condition. And here's 4 hours of the magnetic moment from space, modeled by the Space Weather Modeling Framework. The scale you're looking at here, the color scale is in nanopascals, which is magnetohydrodynamic pressure. And it should be fairly uneventful here over the past 4 hours. We'll also show you Earth's magnetic moment from the ground level, ground magnetic perturbations in nanotesla magnetic flux density. This is geospace delta B, changes to Earth's B field. We showed you the sun's. Here are changes in the Earth's B field from the ground level. Again, pretty unremarkable. We show it daily as it can give insight into anomalies. None showing up here at the moment. Next, a diagram of the solar system. Please don't be frightened of planets. Here's a 7-day forecast. So there's where things will be on Christmas Eve. Yeah, Christmas only 8 days away, folks. Next, a star chart. And if you've got a low horizon, you may see Mars rising ahead of the sun. The yellow line is the ecliptic, and the blue line down there is the galactic plane. The question is, where were you when Deneb rose? More on Deneb in a minute. The most intrinsically bright object visible from Earth. Did you even know that that's a thing? The tail of the swan, Göbekli Tepe, is oriented toward it. Let's take a look at the coronal mass ejection monitors. So we've got old data from the coronagraphs. We're going to show you the view from L1 here, the LASCO C2 and C3, part of the SOHO spacecraft. And although we've got some old data here, we don't see any coronal mass ejections showing up there. Certainly the M-class flare does not seem to have produced anything. Let's do a brief cosmology segment. This one's integrated into the Daily Space Weather video. Check out yesterday's cosmology segment. It's on a playlist at youtube.com/smAsho/playlists. Today's random number is not random at all. It's Cygnus X3. It's, again, the most intrinsically bright object visible from Earth. So other stars are brighter in the sky in terms of their absolute brightness. However, this one is kind of distant, and it's a compact object orbiting a massive star that's about the size of Mars's orbit. I think it's something like 160 times the size of the Sun, is the blue supergiant Wolf-Rayet star. It has like 10 times the stellar wind and in terms of speed and density. It's also a very bright X-ray source because one of the poles of this compact object, known as Cygnus X3, is oriented directly at Earth. Or you could say at the Sun, at our solar system. It's a major filamentary creation point in the Milky Way galaxy. And that line points directly from the Sun to Cygnus in one direction and to Taurus in the other direction. Indeed, the Sun is moving toward Cygnus in terms of its galactic rotation and so on. Cygnus X3, these are the hard X-ray outputs, and you can see here from the historic graph that it is in a very quiescent state in terms of its X-ray output. So that's the past 30 days down here. This is the past 16 years. You You can see it's in a very quiescent state. One of the only known, if not the only known, cosmic ray point source. Cygnus X3, tail of the swan, Deneb, brightest intrinsic object. If you want to read more about it, head to our forum, smAsho.com/forum. There is a cosmology forum there. You can read all about interesting cosmology topics. Let's take a look at the astronomy picture of the day. Don't worry, folks. It's not a fake view of Mars. It's a Geminid over the desert somewhere. No, the photo hasn't been doctored to make it look red so that you think it's Mars. All right. Listen, I don't think space is fake or anything like that. Check it out. You've got Orion showing up in the image there. You can see the characteristic belt of Orion, and also Betelgeuse. So interesting fact about Orion, folks, is that these three stars in a row here, they form a perpendicular to a line that goes right to Betelgeuse, which is the largest intrinsic object visible with the naked eye, the largest single object visible. Betelgeuse, another object so large that if it was in our solar system, you'd be well inside of it. That's the astronomy picture of the day. Pretty good. And it's by Alvin Wu. I think it's the Gobi Desert, perhaps? North-central China is the location of that image. A great blue Geminid showing up there. That's today's cosmology segment. Again, don't forget to check our playlist. There are hundreds of cosmology segments in the playlist. youtube.com/smashamash/playlists. Space weather can charge satellites. It's not currently doing it. We are expecting a precipitous uptick in electron flux. Don't be surprised to see a warning kick off today. Here's the one-year chart of the relativistic electrons. You can see we're still at low levels here following that coronal hole wind stream, and we're expecting an uptick here. So is the Noaa Forecast. There's the 3-day readings from the GOES 16 and 17. They're measuring the electron flux at the F ionosphere layer from their geosynchronous orbit using radiography. Here's the forecast model. And you can see Noaa forecasting a big uptick here. They were totally wrong. I don't know why this is down here. This should still be up here. We're expecting a big increase in the electron flux. It could cause some communications breakdowns. It's not Russia. It's not China. Okay? It's from the electron flux. Satellites shut themselves down when they experience too much charging. Let's take a look at the total electron content, which is essentially the electron content of the inner Van Allen belt. The most likely locations on Earth for GPS errors, and we are seeing some chaos here. We're seeing some anomalous areas of high electron flux, giving us insight into Earth's magnetic field orientation and so on. You can see some errors likely to happen around Antarctica there as well as North America at anomalous times. GPS errors usually happen the most around the equator at noon. That's when you want to have your location accuracy services turned on. In order to give you a more accurate reading, your GPS could be off by thousands of miles around the equator at noon especially. Next, we're going to show you the F ionosphere layer, located at about 300 kilometers of altitude. Here is the ionogram for the previous day. The color gradients here are in vibrational frequency. Millions of vibrations per second is what a megahertz is. Each color blob represents a difference of 1 megahertz. We'll also show you the anomalogram, since we showed you the ionogram. This data is courtesy of the Australian Government Bureau of Meteorology, and we're seeing continued anomalies here in the South Pacific and around the Drake Passage. Keep in mind, Earth's weakest point in the magnetosphere is right around here. The South Atlantic anomaly may be renamed to the South American anomaly, as it's now over the continent instead of over the South Atlantic Ocean. There's also a weak spot down here by southern Africa. Anyway, that's your anomalogram. That's anomaly in megahertz from the 30-day median. Here's the latest image from the ionogram. That's 11:45 Universal Time. There's the anomalogram. Things looking fairly normal at that moment. And let's do bonus features, which are spectacular, by the way. Bonus feature number 1 is the ground-based solar observatory hydrogen alpha data from Cerro Tololo, Chile. Cerro Tololo, Chile. Go ahead, say it aloud, folks. Say it aloud. Cerro Tololo, Chile. Lots of sunspots. Solar flare warning in effect. Coronal mass ejection warning in effect. These sunspots are underachieving. So here's the NASA GOES 16 SUVI imagery. It's just spectacular. It's got a wide field of view. And you can see some prominences over here trailing those sunspots in the south, which again, they've been underperforming. Don't be surprised to see additional M or indeed X-class flares. So here's the latest intensity gram. We'll press refresh so you know you're getting the latest data at high res. So check it out. That's a beta-class sunspot. That's a beta-class sunspot. That's actually a huge sunspot group there. Check out all the umbrae here. These are all beta-gamma class sunspots. Every one of those is capable of producing major flares, and having them in a row like that doesn't decrease the probability. The biggest performer is this one up here. That's 2911. And this leading umbra has actually grown in the past 24. Here's the colorized magnetogram. And we'll just take a trip around this incredible number of sunspots. Again, we're at nearly 130 sunspots here, folks. We went from 0 to 130 in about 3 days. This is 131 angstroms. Just a great zoom here. The fact that we have all of those sunspots in one zoom like this is just spectacular. I'm stoked about it. Here's 335 angstroms. Also good at showing solar flares, but it does only take 2 images per minute instead of 10 like the 94 and 131 angstroms wavelengths at the Solar Dynamics Observatory. Here's a close-up of this most highly flaring sunspot, sunspot 2911. And we'll close out in 171 angstroms, including this M-class flare. A little bit tough to see as there is a lot of stuff going on. In any case, thanks for tuning in, folks. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted, name and news.